Okay, so as you can see, my notes are kind of crazy, but I hope you can kind of see what they say. So I'm going to talk about hemostasis, and that's just basically the stopping of blood flow, like the stopping of bleeding or clotting, and there's 3 steps to it. There's vascular spasm, plated plug formation, and coagulation. But I like to think of the 4th step, I like to think of it as the clot retraction. Kind of just helps put it all together in my head. So the vascular spasm, it's when you get hurt, but the blood flow through the damaged vessel is immediately limited. So it doesn't completely clog, but the smooth muscle of the damaged vessel contracts, and the constricting, it constricts the diameter of the blood vessel. So it just kind of slows down the blood flow. And then the 2nd step, the platelet plug formation, let me get to that picture. There it is. So, if I can get that lined up for you guys. So, a protein called von Willebrand factor, which is secreted by endothelial cells, which are all of these right here, it binds to the exposed collagen in the blood vessel. So here's the collagen, and then the green is the von Willebrand factor. And the platelets come just from the circulating bloodstream, and they bind to the von Willebrand factor and anchor themselves there. So you can see the red is the platelets. And then the platelets increase more platelets, it attracts it. And the anchored platelets give off chemical compounds like serotonin, ADP, and thromboxanes. I think I'm saying that right. And then the serotonin and epinephrine cause even more constriction of the vessel, and this helps the vascular spasms, which is the 1st step that we just talked about. And then the ADP and thromboxanes binds to receptors on other circulating platelets, which makes even more platelet activation. So there's a lot of platelet activation going on, it sounds like. And the platelets stimulate fibrinogen receptors, which are the blue, these receptors. And these receptors bind to plasma protein, and these are called fibrinogen as well, and that's the orange. So basically, fibrinogen just links the platelets together, and then hopefully plugging the opening of the damaged vessel, which this is all the opening. So that is the 2nd step. And then the 3rd step is coagulation. So let me see if I can find that. Oh, that picture. I have too many notes here, and they're not organized. Okay. So here, maybe you can see it better if I do this. There we go. So here, okay, so coagulation or clotting, basically, pretty sure that's what it means. It needs certain proteins, which are called clotting factors. And they're always circulating in the plasma, but they're just in an inactive state. And when the clotting factors find a damaged vessel, some of them become activated and start chemical cascades, which ends in a clot. But the activation can either happen through an intrinsic pathway, or an extrinsic pathway. And an intrinsic pathway is when there's vessel damage and the collagen is exposed to the bloodstream. And so the contact with the collagen reacts with factor 12, which activates it, and then that activates factor 11, which then activates factor 9, and then factor 9 with the help of factor 8, phospholipids, and calcium ions, those all activate factor 10, so right here. And then that's the intrinsic pathway. And then we'll do the extrinsic pathway. So that's activated when the chemical signals from damaged tissues are outside of the bloodstream. And as the blood rushes into the tissue, the inactive factor 7, which combines with factor 3, phospholipids, calcium, right, which is right here. When all those combine, there's factor 3, it combines with factor 3 and the phospholipids and the calcium, and then that activates factor 10 as well. So it either uses intrinsic pathway or the extrinsic pathway, but they all come together to the common pathway. So everything from now on is going to be the common pathway.